Of reminders, make sure you stop by next door, visit the vendors, buy lots of product, send them home with empty trucks and full wallets, please, because they were nice enough to be here to bring all their wares, so buy as much as you can. Stop by our registration table. We still have lots of patches for only $4. Collector's items, there's only a few left, and you'll want to have one because in future years you're going to say, I was there, and you weren't, and then you can show them off to everybody and show you the importance. They will not show up on eBay. And t-shirts as well, a lot of t-shirts left there, and love to have you stop by and take some of those home with you. Check for raffle prizes. We're posting all the numbers on the board. Getting towards the end there, we're going to have a very nice raffle prize to end the evening, so you'll want to buy a couple extra tickets for that. That's it's a picture of it over there. It's a nice levitating globe, which makes a great desk item. It's a magnetically levitated globe that sits floating in the air, which really freaks out the cat. And bus tickets are available. If you have not signed up for the bus trip, the excursion tomorrow, $25. We've got a few seats that have opened up, and see Jim at the registration table if you're interested. All right, let's jump into our next session. Matt Steele is currently the Director of Strategy and Business Development for Vehicle Integration Services at ATK Space Systems. He pursues opportunities for ATK's Vehicle Integration Services division, including the Lockheed Martin ATK Athena launch vehicle, the Dnieper launch vehicle, and other suborbital and launch vehicles. Prior to joining ATK, he was Manager of Business Development for Orbital Sciences Corporation, where he worked on several proposals, such as the Air Force's responsive small space lift competition. He also acted as the lead propulsion engineer on Orbital's Pegasus, Taurus, Minotaur, HyperX, X-34A, and ground-based missile defense orbital boost vehicle. He oversaw the development and successful development and test of the Stage 1 booster on the orbital boost vehicle. He led their team on the X-43A return to flight efforts out on the launch console for 6 Pegasus missions. He was with Thiokol Corporation, which is now ATK. He was the Mark 70 program manager, the associate program manager for SLAT, the supersonic low altitude target, a very cool looking rocket and a great model. Mark 36, Mark 72, Castor 4s, which were the strap-ons for Atlas 2AS. Before that, he was with Hercules Aerospace, developed and tested complex composite space structures used on TDRS and Galileo satellites. I could go on. He co-founded North Coast Rocketry, a hobby model rocket company that designed, developed, manufactured, and marketed high-performance rocket motors and models for consumers. In 1995, North Coast Rocketry products were licensed to Estes Industries. Matt went to work for them as marketing manager. He's designed over 100 different rocket kits for Estes, Quest, Hobby Lab, and North Coast Rocketry. He's an all-around great rocket guy, a teammate of mine on the pod bay doors, the infamous pod bay doors. He's been a member of 5 U.S. international teams. He's the man of bronze. He's won 2 individual bronze medals, and in the team categories, he's won 2 gold, 2 silver, and 1 bronze team medal. He's been on a NAR National Championship team 8 times, and he's been a member of NAR Section Champion 9 times. He was a NAR trustee for 9 years. He's been contest board chairman, contest director for 2 NARMs, NARM 30 and NARM 48, 2 very successful national meets. Anyway, he's from Ohio. He's got a BS in physics from the Kent State University, an MBA in technology management from the University of Phoenix. He's going to be talking to us today about future launch vehicles, and he's got some great models here to show you. Please join me in welcoming Matt Steele.
Thank you very much, Pat. You'll find a $20 bill slipped inside your credit card there for that, so I think that's what we agreed on. I've kind of put this together, and this also can be a little bit of give and take, but just some stuff that's future launch vehicles, and I've done it from 2 perspectives. One is to kind of give you sort of a professional outlook of kind of what's out there, but 2, also neat stuff that would be fun to fly. And so I'm hoping there's at least one in here that you haven't seen. That is at least my goal, if not more. I'm about 1 mile wide and 1 inch deep on any of these, but you can try me and I can see what I do know as we get through them and like that. And I'll start off by saying that one of the cool things is, and the first one I want to talk about is SLS, Space Launch System. And I was able, we have a model shop at ATK that builds fantastic models, and a guy by the name of Mark Waukee that not only builds models, but does great artwork. And so when Pat asked me to come down here and speak on this, it was like, well, I want to see if I can get one of our SLS models to come down so you guys could see how neat this stuff is. And it turned out through hook and by crook and by knowing the secretary of one of the division managers, we were able to get this, and this actually is down here in Florida, so Moose Levine and Dave Solberger went over and raided the offices on Thursday and got it, and will be taking it back. So not only did we get it, I didn't even have to schlep it all the way from Utah and have to take it back and like that. And we got the really cool one that has the launch gantry. So after the presentation, if you want to come up and take more pictures or get your pictures taken with it, that'll be fine. Also, just so you know, everybody who waits to the end, I have a limited number of ATK 2014 calendars that you can take. This is your reward for coming to the session, and obviously, because I like people to sit in front, those who are up front will get grabbed first. And then also, I have a 2014 calendar with SLS. So, like I say, after I finish, those are free to come up and to take. So you get a little bonus souvenir. Okay. How do I get it to go to the next page gracefully? We'll try that. So this is NASA's Space Launch System, and this is the replacement for what was supposed to be Ares 5, okay? Early on in the Obama administration, they canceled Ares 1 and Ares 5. This is what eventually has evolved out of it, which is called SLS. But the other thing is these comments are mine. They're not ATK's, because I'm going to make some politically unpopular comments as we go through this, just so you know. They're not ATK's, they're mine. But this has been nicknamed the Senate Launch System. The administration really was not behind this, and it was some powerful senators that had ensured that this is getting built. The cool thing is the parts are coming together, and this thing is going to fly soon. And ATK builds the solids that are on this. There's some Rocketry stuff on it. There's some Lockheed Martin stuff. There's enough to keep everybody happy as we go through. But the real answer is this thing is going to fly soon, and it's going to be really cool when it does. And so, to give you an idea of how big this is it's Saturn V sized. So over here we have an Atlas size. This is a SpaceX Falcon 9. Delta IV Heavy shuttle, Saturn V. You can see where SLS manned is going to be, and then SLS cargo is going to be even bigger. And so, incredibly cool rockets. Going to put us back into the Saturn V launch capability for all sorts of missions. This week they were talking about in the Senate of using this kind of rocket to do a Mars flyby. They've talked in the past about doing a rendezvous with an asteroid and actually trying to bring some of that back. It's not clear how all that's going to play out. I think a lunar flyby and a lunar mission is still in the works in the background and will bubble back to the surface. But it takes time to develop a big rocket to go off and do those kind of missions, and that development is now underway. So it's pretty cool from that standpoint. We're going to have a big rocket in the stable pretty soon. So let me scroll down a little bit. So, okay, Orion at the top is being made by Lockheed Martin, and that's a crew capsule. And it looks like Apollo on steroids, okay? The big difference between that is I think it's going to carry 4 now. It had been 6, it's moved to 4, it'll probably stay at 4. But it's being designed in such a way that that it'll be able to do deep space missions. So it has the radiation shielding, it has longer capability for, going to space and orbiting for an extended period of time. So it's designed for deep space missions. And this should be the capsule that should carry us for probably the next 20 or 25 years. At least that's the idea that they're looking at. They will be expendable. However, one of the things that's being looked at is after they land, they may be refurbished and be used again. They actually think that that's going to be possible with these as they go forward. Pretty cool. It has a launch abort system up here, up on the top, that's made by ATK, and it's kind of like the Mercury escape system, where it tows the whole thing away, and it has a reverse flow rocket motor where the gases come down and then vent out, nozzles that make it do a U-turn and go out. And they've actually done a test of that, and I'm going to show you something of where they're going to go do Little Joe 3. They're going to do that kind of test again coming up soon. And Pat will be very happy because the pad where Pat works at is where it's going to get done. We have some adapters, and then also they have what they're calling an interim upper stage. They have plans for a grand J2X upper stage, but liquids take a long time to develop and a lot of money. So that's been pushed off until a little bit farther in the future when there's more of a requirement. And the stage they're going to use right now is based on the Delta IV, and it has some modifications, but relatively minor. The core stage is a new one developed for Space Launch System, and the engines are basically expendable versions of the Space Shuttle engines. And so now this version is going to have 4 engines in the bottom. There had been, again, 6, depending on how it plays around. They have changed the specifications of this over the last couple of years. But now that they're starting to build hardware, this thing is starting to settle in, and this is really what it's going to look like. And then the solid rocket boosters, which is an ATK that we manufacture. This is a 5-segment solid rocket booster that's manufactured in Utah. The ones that flew on the space shuttle were 4 segments. And it's not just as easy as we made another segment and dropped it in. We literally changed the interior configuration of the motors to match the thrust levels that this rocket needed as well. And go ahead.
What was the motivating factor to make them not reusable? Was it reuse on the shuttle had not been terribly successful or cost effective?
You gotta bring
I'm
it
going to
back.
go off in the weeds, but I'll tell you. I'll say so. Reuse on the shuttle was not really cost effective when it was all said and done.
Okay.
Okay. The reason though that reuse or recovering them was very, very useful was the fact that we built a database of knowing exactly how these motors worked. Okay, and then for a manned space flight, we built really good analytical tools and had a really good database, because between flying and static tests, we had about 230 of these. And so analytically, we understood them real well. But by the time you brought the parachute and you brought them back and you towed them in and you stripped everything else out and cleaned them up, it was just as cost effective to start with fresh steel again. And so these, though, are going to be filament wound carbon fiber for higher performance. And there's still a lot of unknowns when you do high impact loads on carbon fiber. And so the inspection processes are kind of undefined, and so it's easier to just go to a single use and not worry about trying to re-inspect anything once it hits the water to come down. So you get higher performance. The other thing is you take out the weight of the recovery system, then that's not a weight penalty either. And so they really kind of took it out because there was not a big cost benefit for usability, and they wanted the performance increases of the filament wound carbon fiber case and the lighter system. So, question?
Okay, the picture is white, but it's still going to be orange foam underneath that, isn't it?
I think so. We think at this point it is going to be orange, and actually I'm surprised this model has a white one, but we have a lot of models now that are showing up in orange. And so it's the same technology that was used on the shuttle main tank, okay, being made in the same facility with the same foam, with some improvements so it doesn't come off as easily. And I think it is going to be orange. Yeah, so it doesn't shed. Although this one is a lot easier to do that. I mean, they're a lot less worried about that simply because they don't have that orbiter and all the funny drag things that were going on with the orbiter on it. But yeah, I do think that when the first one flies, I'll be surprised if it's white. I believe it will be orange from all that I've seen so far.
So this will be the first time a graphite composite case is used on that size of a solid rocket motor, right?
It will be the biggest composite case solid rocket motor made to date. Now, 2 data points. So they had made, okay, prior to the Challenger incident, Hercules had made solid rocket motors with the filament wound graphite at that time, and they were being fabricated and they were being tested, but they had not cast live motors. but they were busy testing them. So if you want to go to the Alabama Space and Rocket Center and you see the space shuttle model that's sitting outside on the pedestal, those are the carbon fiber filament wound motors that are on display there. They made an inert set, and that's where that set ended up. So they had made a bunch of those, you know, for testing and everything like that, but never flew them. Okay. And then secondly is we did Hercules. ATK bought Hercules, then they bought Firefall, so it's all now one unhappy family. But the strap-ons for the Titan 4B are the largest segmented solids that have been made with a filament wound case. And so the scaling up from that is not a big risk because they're just a little bit smaller in diameter.
So you're running nearly the same MEOP on these?
No, these run higher. These run higher. The steel cases we're only running 700-800, and these are going to run at 1200. So we're going to get more efficiency out of the propellant as well. Yeah.
The propellants, any new propellants like CO20, anything like that?
Not on this one. It is an improved. On the shuttle one, it was a CTBB, which was kind of an older, you could think epoxy-based kind of propellant. It was really hard. And that really kind of got evolved out of most systems in the 80s and 90s. But because the shuttle started early and they'd always made it, they stuck with that throughout the whole thing. Well, we're going to switch to HTPB, which is just like what's in your Aerotech stuff, okay, for these, which we get additional performance. There are some issues because it tends to be a little bit softer than what the CTB propellants were, and you have to worry about pressure loads compressing the grains. Hercules, when they made that first big Titan 4 segment, actually had a situation where the propellant compressed and it choked the throat and they blew the hell out of the motor. And the propellant was actually formulated a little too soft and too rubbery. So they went back and formulated it into a much stiffer formulation, and that's what they're going to use in these. So again, because of some of the tools. So that is a propellant upgrade. However, you know, that's a propellant that's pretty equivalent to, quite frankly, a lot of Gary's state-of-the-art stuff right now. It's not real sexy. It doesn't have any fancy additives in that. I will say that I'll come back to that in a minute. Let's put it that way. I have something that's going to use a sexier propellant that we're working on coming up. So the big thing here is this is a chute, and this is part of that core tank, and they're building real stuff. Okay, so finally we're building real stuff. It's not just PowerPoint slides. So that's the core. There's a payload adapter that they're getting ready to fly. So it's actually built, and they're talking about a test flight. I don't believe it's going to be in 2014, but that's the official word right now. So this is Matt's opinion, not APK's. But they're getting ready to fly Orion on a Delta IV at the end of this year or very early next year. Yeah. So there's still a lot of things to get done, but I mean, hardware is starting to take place, so take shape. So let's see if I can. And then RS-25, the test area upgrades are being made right now, and they're going to start test firing the RS-25 later this year, down at the chute. And it is an upgraded version of the shuttle main engine, but it's designed not to be reusable. They're going to dump everything on this bird. It's going to be a huge expendable bird. And then new upgrades are being tested for the solid rocket boosters. We've actually fired 3 of these solid rocket boosters up at our place already. We actually tore down one of the big 4-segment stands and had to extend it with more concrete and build it for the 5-segment stand. We've tested 3 development motors, and then we went and made a qualification motor, and we found an unbond in the back end. Now we've made 230, and we was like, wait a second, what happened? Now we did change some tooling, and we did some other things. So it's like, okay, we went back and looked at the tooling, and we made another aft segment, and we voids in it again, and it really had us scratching our heads. What we think we figured out, they've made the 3rd one now. And what they think they figured out is that when we were in shuttle production, we were making these things and casting them on a real regular basis. And none of these things, after they had the rubber added to the inside of the metal, would sit longer than about a week until it was lined and then cast with propellant about 2 weeks later. On these test motors, because they had more time and were working some things out, there's a month to 6 weeks before when they did the rubber to when they went and did casting. And apparently, that extended period of time created gas and bubbles that we ended up seeing in the back end. And so a slower tempo, even though and the materials were pretty much the same, a slower tempo and a change in the processing changed what we were doing. And again, we've done this for 30 years, and it's reached up and kind of caught us by surprise. So we've done a bunch of test articles, we figured out, we think that's what it is, and like I say, we've made a good aft section. So the static test for this will be, they're not saying officially, it probably will be this fall. And part of the reason is after they finish the motor, they have to put it in temperature conditioning for 2 or 3 months to get it down to the right temperature to fire it. And that you have to, it's a lot of thermal mass, and it takes a lot of cooling to bring the temperature down. So they'll do a low fire temperature. But we have 3 successful ones. We built all the segments now. They're getting the final approval from NASA. Then they'll go ahead and assemble it and put it in the stand, and then roll a big conditioning building over it, and then start to bring the temperature to the right thing for the static test. So that's coming up. And I'll tell you, so the static tests are free to go see. Anybody that wants to get out there, there's a public viewing area. Yeah, you live close. You should definitely go. And I'll tell you, having seen shuttle launches and seen the static tests, in some way the static tests are much more impressive than a shuttle launch, because in the shuttle launch, in 2 minutes when the solids separate, it's like it's gone and it's this little point of light. When these things rock and roll for 2 minutes, okay, they shake everything in you, and they have low vibrations. You'll feel your organs shake against your ribs, and you'll feel your pants just rattle. And it sits there, and it goes, 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 and it goes for a full 2 minutes, and you get a lot better idea of what the astronauts are going through during that time. I took my father-in-law, who I don't ever really think he believed what I did, until I took him up on a tour in one of the tests, and we saw the test, and then he got it. And I said, just remember, I said on the shuttle there was 2 of those, plus the liquids. I said, you'd only got about, 30% of the show when it was all said and done. And so it's really impressive. So we're going to be testing one of those coming up probably in the fall, I think.
So Matt, are we less than 1,000 seconds total development test time running on this?
We look at it as 3 tests. I mean, so it's 3 2-minute tests. But we've done, on the development program, we did a hot, cold, and a nominal. And for solid rocket motors, that pretty much envelopes what we're worried about, okay? The cold tests all the joints, and it tests some of the nozzle materials that we're worried about. And the high temperature test turns out to be the one that everybody really worries about, because it drives the motor pressure up to what your maximum is, and so you test all the pressure integrity of all the things. Part of the reason we run it at a higher pressure is that we can test the filament wound cases to a much higher pressure with a greater degree of confidence than they could before Challenger, and so they're pretty confident in using them. So yeah, we think the 3 development tests, they're going to fire 3, maybe 4 still budget issue qualification motors, and then we'll be ready to go into production. So that's really all we need. Liquids is a different story because they do run them, and liquids also, I mean, 2 minutes is a long burning solid rocket motor, but the liquids, can run 8 minutes, and it's a different story. So it's not apples and apples kind of comparison.
What's the difference in chamber pressures between the cold and the hot test?
Sometimes it may be as much as 200 psi. It depends on that. I like to say, I think on this it's probably even a little bit less because, again, the HTPD propellants are a little less sensitive to temperature differences. But it does have it, and then the colder the motor, and you guys know this, the longer it burns.
Yeah.
So.
And on the high end of the pressure on the hot motor, what pressures are you running?
About 1,200 psi.
1,200. Okay.
Yeah. So, and like I say, so the neat thing is it's coming together. And I think we're going to get to see that fly, and it's going to fly out of here, and it's going to be cool.
I heard about the recovery of some of the older Saturn V engines.
Mm-hmm.
Was ATK part of that?
No, Jeff Bezos at Amazon did that.
Yeah.
And ATK didn't build that. That was actually built at Marshall with the
Okay.
Von Braun team and everything like that. But they did get them back, and they
And
supposedly...
they're refurbishing them?
No, I don't think they're refurbishing. But I think what they are looking at is...
For a museum.
They're putting them in a museum, but they're
And then they're refurbished.
There's a company called Dynetics that's proposed to maybe use that as an upgrade in this SLS core stage. And so they're looking at some of the engineering to understand, post-flight, how those things work. They did them, post-test, but flight sometimes does different effects. And that would most likely they're going to end up in the museum after they've been looked at.
Okay. It may be confusing that we had a couple of F1s that were left over surplus that we tore down and rebuilt. And
Yes.
They're
Yes.
using those as pathfinders for the
Yes.
hardware.
Yeah, that's going on, yes. Okay, so, and then this is the cargo lift capabilities that they're talking about as well. And again, for you fantasy scale modelers, this is another one that's going to be pretty neat. And I'm going to plug in for Ryan right now that fantasy scale is one of the events at NARCON, so.
I worked on one of those already.
Okay.
It didn't end well. That's when we launched out at 39A.
Okay.
Oh, no.
Okay. Anyhow, so like I say, so big fairing, this is mostly being talked about. It doesn't have a specific mission yet, but it's a good bet that this is going to get built if the other core stage gets built like that. I believe that for some of the grand experiments and stuff that's eventually probably going to go to Jupiter and Neptune and Uranus and like that, this is probably the rocket that's going to take those experiments out that way. So that's pretty cool when it's all said and done.
Hey Matt,
Yeah.
do you happen to know, just for little rocket people, is something like that passively stable? Can it be?
Yes, absolutely. As a matter of fact, I'm working on a North Coast version of this right now.
No
So-
clear fins, no.
I think you need clear fins. I think you need clear fins. Yeah.
That would
Yeah.
be not stable.
This one might be stable without the clear fins. I mean, the old Saturn V's, what was it? The Estes one is stable with a little bit of oversized ones, and the Centuri had the slip-on ones. I mean, it's fairly close, depending on. And I've flown plastic model Saturn V's without clear fins and been fine because of the cone shape coming down tends to make it more stable. This payload version with that hammerhead, much more unlikely. You're probably going to need clear fins in order to make it go. Unless, of course, we perfect onboard thrust vector control and guidance computers and can vector the four motors, then we can have flight control. And
I'll take care of that next week.
I'm sure, John, you'll be working on that in the next couple of months. So.
Do you know where I get some clear plastic?
Talk to me later. Anyhow, so that's pretty. So like I say, and that's going to be the big thing that's going to start to get momentum over the next couple of years and towards hopefully a 2018 flight, and hardware is being built. This is Stratolaunch and this is Air Launch System. Okay, this is Pegasus on steroids. Okay, in a way, this is a company funded by Paul Allen, and this is designed to take basically what they learned on White Knight in Spaceship One and White Knight 2 and Spaceship 2 and scale it up to a bigger cargo rocket as well. And originally SpaceX was picked to do the center rocket for kind of thinking in this case the plane is stage 1 and then the rocket is stage 2 and stage 3 to orbit, and the plane then comes back and lands. This is going to be based mostly out of Mojave, but they've made arrangements that it can fly out of here, and it probably can fly a couple other places that have a long enough runway. SpaceX was not able to do the engine for the stage 2 and the stage 3. It really required a lot of changes in the tank design and structurally and everything like that. It just didn't fit their production line. So they went to Orbital, who has experience with Pegasus doing this, so this is why it's scaled up. And they came to ATK for the stage 1 and the stage 2, and these propellants have the hottest, most efficient solid rocket propellants that have ever been put into a production rocket. And quite frankly, I was a little surprised that they went as far as they did in terms of pushing the performance limits, because we tend to be pretty conservative. But this is a quantum leap forward in ISP over most of the solids that are out there today. So, and we've done research for 20 years on different things, but we've never been afraid to put them, or we've been afraid to put them in because we either didn't need to pay for the performance or we didn't want to pay for the ingredients. The performance characteristics on this thing, because there's some limits of how much weight the airplane can take off and how much payload they want to put into orbit. drove us to go put some really advanced propellant formulations into this. And so,
Just tell me you're not putting beryllium in it.
no beryllium in it. No. But lots of high energy, nearly explosive items instead.
Yeah.
So, and then and so one thing is this is pretty much all that is public release. They're not saying a lot about it like that, and so we don't know what the third stage is right now. We know who they've talked to, but as far as we can tell, they haven't finally decided on how that's going to go. It really needs to be a high energy liquid stage to meet the plane liftoff weights and then the performance. But if you have a liquid as an upper stage, you got to either keep it cold and you got to top it off and you got to carry that on the plane, and there's a whole bunch of other issues. And so we're going to see how that plays out. But the plane is being built. They have a huge hangar out in Mojave. This plane, just so you know, is the equivalent of 2 747s side by side. Okay, if you thought the Spruce Goose was big, okay, this is going to dwarf.
Matt, I've always been kind of curious about the development of the airplane. And maybe somebody here can fill me in on the historics of it, but the Germans had something like this in World War II, right? But so between World War II and White Knight, nobody ever thought to going back to this kind of a, I mean, it looks like a glued together design.
This is a rattan. This is a rattan design, yeah. But and they've taken a bunch of parts. They had 2 747s that they're taking a lot of the parts from to go do this, I think, 10 a year. I mean, they're not trying to invent too much, but it is going to be an all-composite aircraft. And
I mean, from a balance point of view, it makes sense. From an aerodynamic point of view, you're going, oh my God, that's a lot of stuff that's flying through the air.
But you know, I mean, they've kind of gone progressively, scaled the design up through, you know, White Knight 1 to White Knight 2 to this thing. And so it's rather interesting. This is supposed to fly in they said 16. I think it's going to be closer to 18, okay? But, I mean, it's got real money behind it, okay? And it is going to fly. I mean, we've got paid a huge chunk of money. We just finished the preliminary design review. It'll go into critical design review. And it's a fast-track program, so, I mean, because it doesn't have any government restrictions or things like that, trust me, it makes a huge difference. So it's pretty exciting.
How much larger is this than Pegasus?
Okay, good question, because, so, Pegasus is a 50-inch diameter motor, okay? When I worked on Pegasus, it was really, and it's about 50 feet long, so it's about as long as this room, okay? And it's probably, think about it, is not quite as wide as this table, okay? And it weighs about 50,000 pounds. And so I always thought when I worked on it, it was pretty big until they rolled it out under the L-1011, and then it's tiny. You know, that L-1011 is a big plane. This is 146 inches in diameter, so it's 3 times bigger in diameter. Yeah. And the rocket weight, okay, with payload, it's got to be less than 500,000 pounds. Okay, so this is one big cookie. Pegasus can put about 500 to 1,000 pounds in the low Earth orbit, okay? This is targeted to put closer to 8,000 pounds in the low Earth orbit, depending on what the
It's kind of in the Delta II class.
It's supposed to be in the Delta II class, exactly right. Yep. Wow. So, but this is pretty cool, and this is, like I say, this one is, I believe, is going to get built because Paul Allen wants a legacy. So, you know, our guys are worried about he's going to run out of money. No, Paul Allen's not going to run out of money. You know?
Since it's going to be in the Delta II class, is it going to be cheaper to operate?
We'll see. That's part of the internal debate. I don't know. It should be competitive with the other things that are out there in the Delta II class. Where the final price ends up, a lot of it will depend on all of these. Okay, price depends on how many you build and how many you fly in a year. The hardware comes in at a pretty much equal rate, but it's all the engineers and crew and everything else, and your flight dynamics guys and all that, and how often you fly has a lot to do with what price it is. So, I mean, one of the reasons SpaceX has been able to quote a lower price is that if they really are going to fly, you know, well, they claimed 13 this year, they won't get 13, but, you know, a lot of flights, then you can amortize a lot of that personnel cost over a number of rockets, and that's how one of the ways you can reduce the cost.
Okay.
So this, like I say, this is pretty cool, and coming to an airstrip near you soon. Okay, this is the Blue Origin New Shepard, which I kind of call funky but chic. This thing is actually scaled. Okay, this little ugly thing is actually flown out in West Texas.
It hovered, actually.
Yeah, yeah. And so this is so they're doing a propulsion module and kind of a crew capsule, and this is kind of a pathfinder for what they want to go do. Yeah, because like I say, this is a shot where I think it's landed. That's a post-landing shot where it went up and it came over and translated and came back down. And the thing about Blue Origin is they're not talking about anything. This is very hard to find anything. There's been a few people I've talked to who have been into their place, but they're not bragging. If SpaceX is the PR, you know, Diva's over here with everything that they tweet out, Blue Origin is over here and not saying anything.
For the
But-
51
You could
of
tip
it.
bash it off a baby Bertha, don't sweat it.
Oh, yeah, yeah. So, and anyhow, and where that's headed to is this orbital reusable booster that they're talking about. And so they're going to put a capsule on and they're going to fly that first stage and add it to that, and they've actually built a capsule. And the cool thing about what these guys are talking about doing is they've talked about, and they went out and have gotten a patent for launch vehicles with, this is just not the right size, yeah, with deployable deceleration systems. So apparently there's been some other, come on. But anyhow, they're talking about where they would take it up and then deploy it and come back. And so for future scale, anybody that wants to build something with a really cool flight mission points, this is one that will definitely get you there. This is pretty darn cool to see that somebody's even thinking about that. And I mean, you know, this system would be in addition to, you know, the retro rockets that would be lowering it down. So, you know, it's conceivable that these guys are going to test something in this configuration and go out and do it. So again, something to look for. Bezos is like Paul Allen. He's got more money than what he knows what to do with, so it's a good bet that this thing is going to get built and go forward. And you'll hear in my discussion a lot of how these things work. It all depends on the money. So this is another money, and this is Spaceship 2 with White Knight 2. Okay, this is for Virgin Galactic, and their logo is Book Your Place in Space. And they're getting close to being able to offer tourist flights to the edge of space. Now, understand on this, they're going to space. They're not going into orbit. It's a very different animal. So for on space, they're going high enough to claim that they're inside or outside the envelope of the Earth's atmosphere and in space, and they come back in, and they plan to leave out of Las Cruces, New Mexico, and land back in Las Cruces, New Mexico. You know, to go into orbit requires 17 or 18 times more energy than what these guys are doing. But this is going to be a hell of a ride, and you're going to be able to experience zero gravity if you get to go. Branson said that he and his kids are going on the first flight. They've said it's going to be in 2014. I really think it's going to be early next year, but it's coming. And the airplane and the Spaceship 2 are built. That's an actual in-flight test photo from a little camera looking up on the tail, looking down. And that has a hybrid rocket engine. Now, being from the solid rockets, my contention is that hybrid is a combination of the worst of the liquid and the solid. But I mean, we've done them before. We know how to do them as well. And quite frankly, for a manned application where you need to be able to throttle or turn it off, hybrid is a pretty good application of it like that. But they have struggled and they have fought, and they had unfortunately some fatalities when they were working around it a couple of years ago, which has slowed the program down. But certainly the initial incarnations of this is going to fly on this hybrid, and it's a polybutadiene rubber based with oxygen flowing through it, and so when it flies, it looks like a burning tire. So that's a picture of she rocket and rolling. but it definitely looks to be fun. So this one, for those of you again keeping the scorecard, this is a scale model because this is flown under rocket power, but it's a pretty cool one, and hopefully they'll be flying a lot of them. And then this also features what they call a feather reentry, which is one of Rutan's very intriguing innovations of how to do reentry. The problem on the shuttle is it generates a lot of heat with the way that it comes in, and the shape is designed to give it some stability control. Because of the way that he's got this, he'll generate a little less heat and he'll have a lot more control as they come in on the re-entry phase. And so it's a very unique. So that literally pivots up at the joint and gives them additional control, and they'll fly that almost all the way in to touchdown, and then at the very end level it out and make it look like the regular airplane. So it's pretty cool. I think next week they're going to announce the 700 and 701st customers to go fly on this, and I think tickets are about $250,000. So you know, it is possible to get in line to go do that. So, but surprisingly, that's a lot of interest in that. So, and I think same thing again when they're up and they're flying in the flight rate, that ticket price may come down. It'll be interesting to see. And you know, they designed, you know, this is going to fly a long time. So anybody in here wins the lottery, they might be able to go on it. And that is certainly a potential.
Matt, there's a big difference too managing the thermal loads at Mach 22 on re-entry and Mach 3.
Very much so. Very much so. Yes. Yes. So part of that discussion on the hybrid is that Virgin Galactic has also announced Launcher 1. And Launcher 1 is to replace the manned Spaceship 2 that you saw that basically provides joyrides up and back. This is actually designed to put affordable, it's supposed to be affordable to put little satellites into orbit. So this is now mini Pegasus. If you're going to go to the other side of the scale, and we already saw what Stratolaunch, potentially. Okay, potentially CubeSats, up to, they're talking, I've heard between 50 and 100 kilograms. So you know, you could put some. The interesting thing about this is if you look at the original concept and when they originally started talking about this, they would have used the same hybrid engine that they had in Spaceship 2, and you know, get some economies of scale to carry it over. But when they started to do the performance calculations, they realized that they were not going to make orbit by doing that at all. So they're developing a LOX kerosene engine that'll be in the first stage of this to put it in orbit, and then another LOX kerosene second stage to put in small payloads, and that's under development right now. So that's a really intriguing design, and they've hired a lot of good people out at Mojave to put this together. So I think these guys will be successful in doing this. When this gets introduced and how much it really costs will be up in the air.
Is that White Knight 1? Would they use White Knight 1?
No, it's a White Knight 2.
So
It's a White Knight. It's another White Knight 2. Yeah, because it's heavier than anything. That White Knight 1 basically has been retired, and so. But I think their plan is they've got one White Knight 2, and I've heard some discussions they may build a second one. It's not clear, but the real idea is to keep that plane in the air as much as possible. So if they don't have enough manned flights, they come over and they fly small satellites. And that it'll, like I say, it'll be interesting to see how this all shakes out. And a lot of it will depend on the price that it takes to put the small sats into orbit too. So there it is again, showing kind of the concept, and it's a two-stage deal, and that's what they're talking about. And this is Soyuz 21V, okay, and this is a major departure from an earlier Soyuz rockets. I like this picture because here's the launch pad. They got other stuff sitting out there like on a museum, and the shop, okay, so you can see, you know, and the snow's on it, you know, stuff that they've had. But this is the Soyuz 21V, okay, as in Victor. There's also 21B as in Bravo. That's kind of what we think is a standard Soyuz, but this is basically the Soyuz like we're used to without the four strap-ons. And there's a picture, kind of a side view of it like that, and you can see that it's kind of got the fold out and back in. The big thing is they replaced the engine that's in the Soyuz with a single chamber NK-33, and so their thought is that'll be more efficient and lower their costs as they go forward. And part of what the the Russian Space Agency wants to do is to move that as part of their boosters of the future. And this thing actually flew right after Christmas, so this is now a scale model now, okay? And the interesting thing is there's about 3 public release pictures of it and nothing else. So we were told that the flight went well, and I've heard from independent sources that it did work okay, but they've not made a big amount of PR on this, surprisingly. And they had talked a lot about it coming up, so we're not sure when the next one's going to fly, how it's going to be, but that's definitely a new, and it's a newer direction. So like I say, it has 1 nozzle down at the bottom instead of the 4 little ones like you're used to seeing on the Soyuz. Let's see. Then the Falcon 9H. This is going to be one big mama too. SpaceX claims that this is going to have more lift capability than twice a Delta II Heavy, and this is basically a Falcon 9 with 2 more Falcon 9 first stages strapped on, and so it's going to have 27 of their Merlin engines on the first stage. So
Talk about redundancy.
It's better.
it presents some interesting challenges. I mean, yeah, if they have 1 engine go out, they probably can still make it to orbit, but now you have to manufacture 27 to get into, to get into the space vehicle to go. And, these are still not easy engines, although SpaceX has done a lot to make them a lot easier to manufacture. They're still not real quick and real easy to make. I mean, they've struggled to keep up with their engine manufacturing line on the stuff that they're doing right now. To multiply that by 3 becomes a bit of a challenge. However, if they get that worked out and you're making 27, they should be considerably cheaper than somebody who's making 1 MK33 or some of the RS-68 stuff that we're doing. So it's interesting to see. That's due to fly out of here, and SpaceX has leased the pad, one of the shuttle pads, and that's what they're going to modify to fly this out of.
What's going in California this year, isn't it?
Allegedly. Allegedly. Yeah, it's supposed to go out of California first. It'll be interesting to see. But the pad that they build in California is big enough to accommodate it. That was the one thing. The pad over here at LC40, is not really set up at all. But when they did put the pad in over in California, Vandenberg, it's set up to accommodate the Heavy. Like I say, they had 13 flights scheduled for this year. Whether this thing makes it in time would be, I doubt it. But it's coming soon, one way or another.
Matt, can I just ask a question just about Vandenberg? Is that just used for polar
Pretty
orbits?
much so,
It's
yeah.
not used for equatorial orbits, right?
No, The Vandenberg, a West Coast launch site like
Yeah,
Vandenberg or Kodiak are generally for polar orbits that go this way. And if you want to go into geosynchronous or to ISS, the Cape or Wallops are the places to go. And the closer you are to the equator, the easier it is to go into
Yeah, you get that
geosynchronous. So,
Extra 1,000 miles.
yeah,
Well, Vandenberg was for anything retrograde.
yes, yeah, if you do. We're
There's no
very,
place you can do it.
yeah, very few things fly retrograde, but if you need
because
to
you
do
need
it,
extra
that's what
power
you
to
do
do
it
it.
from, yeah. So anyhow, this gives you an idea where Falcon 9 is going to fall into the scheme of things. So SLS and this may be in the same class. It's hard to tell where this thing is going to end up performance-wise and like that, but it's certainly going to be a huge rocket, a little bit less than Saturn V capability, but definitely going to be a big rocket. This is Little Joe 3. This is an abort test booster, and they've already done a pad abort test out at White Sands with the Orion capsule and the launch abort motors that are in here, okay? And the next phase of the testing that should be out here at the Cape at LC46, don't know exactly when, but probably 2016. This is going to be do what they call high altitude abort. So they're going to boost it to a certain level and then trigger the abort system and make sure it works. This program, if it goes like it was originally planned, should be at least 4 flights. And what's interesting about this is a single stage rocket, and it has a Peacekeeper first stage buried in here, okay? The Peacekeeper first stage is like 92 inches, and I don't know what this is. This is like 3 meters or something like that.
5.5.
Is that what it is? Yeah. And so they built this huge cam around the motor to give the right aerodynamic characteristics because they needed to have the right interface here to make sure they had the right separation dynamics. And they're going to fly this out of the Cape to test the abort system in various scenarios. And so Orbital got the contract to do that. Orbital has built most of the hardware for this, and then when Orion kind of got delayed and like that stuff has been put in storage, but now they're making preparations to bring everything out and bring it out and do the test flights in 2016 and 2017, I believe. So I actually worked at Orbital on part of this proposal, and I kept telling my boss that we needed fins. My boss was a model Rocketeer guy too, who loved the Little Joe 1 and the Little Joe 2, so he knew, but we just couldn't make it work. So,
What does the back end of that look like? Is it just struts supporting the outer can?
Yeah, it's a little bit enclosed so that you don't get some flame recirculation in from the nozzle, but I mean it's a big tin can. So there will be a Little Joe 3, and that's a coming attraction, all tied into Orion as well. This is Athena, and this is what I've been working on. And Athena actually flew a number of flights and then went into kind of a mothball status, and I've been working with Lockheed to bring it back out. And the interesting thing for you guys is, so we have Athena 1 and Athena 2 on NASA and Air Force contracts, but we're coming back to the Air Force and going to do something called Athena 2S that has a bigger payload and has anywhere 2, 4, or 6 Orion motor strap-ons. They're the same as the Pegasus first stage motor. And then and that's coming back. We've also looked long and hard at something called Athena 3, which is the one that would use a 3-segment RSRM. And that one has no technical problems, but you have to go build a new launch pad for it somewhere, and that turns out to be expensive. So whether Athena 3 gets to be seen is up in the air, but there's a good chance that Athena 2S will be there. And again, for scale modelers, that means extra strap-ons, so that's all good as well. And that's
Delta class?
Pardon?
That Delta class?
That would with the, yeah, you can go. That would because Athena 2 is the biggest of the small launch vehicles, and you would go with the bigger payload fairing. And 2, if you go with the 6, you actually edge into the Delta 2 heavy class and like that. So that's envisioned as a Delta 2 replacement. And that, yeah. And then this is Liberty, and I've titled this "Looking for Love in All the Wrong Places."
Aries one.
Well, yeah, it looks too much like Ares 1X, and NASA didn't want that after they canceled Ares 1X, so that's why it didn't get picked. But it's still out there, and if the right investing or right launch opportunity would come along, it would be worked on. But right now, it's a good candidate that this is probably going to stay forever at fantasy scale. This is Matt's opinion, not ATK's, but when ATK did not get this picked for the commercial crew, this has been a difficult thing to justify a business case to go forward. So I think it's a good rocket, but it's in the wrong place at the wrong time.
That's basically off the shelf.
Absolutely, yeah. And I mean, there's some really exciting capabilities in it, but politically, it was in the wrong place at the wrong time. This is Angara. Okay, this is a family of launch vehicles that the Russians have been developing that are intended to replace a lot of the things that they're doing right now. And so again, it kind of has a modular approach to it, where it has a core and then use of multiple cores to give it additional lift capability. And here's kind of that nice illustration of it flying, and you can see that it has a 1 core, a 3 core, will go to 5 and even 7 as a big thing. Now they're building, because Baikonur is in Kazakhstan and not in Russia, okay? This wasn't a problem, it was all the Soviet Union, but now that Russia and Kazakhstan are separate, Kazakhstanis have become very good capitalists to the Russians as well, and every time that there's a launch out of Kazakhstan, the amount of money that the Kazakhstanis charge the Russians seems to go up, but it's in perpetual negotiation and that. So the Russians, getting tired of that, have actually commissioned a new launch area called Vostochny, up near the Arctic Circle that this is intended to fly off of, and this will be the first vehicle to fly out of that. And so eventually the Russians intend to be totally abandon Baikonur and go to Vostochny instead, and stop paying money to the Kazakhstans. So it's going to be interesting to see how that plays out. This thing has been talked about a long time. It's behind schedule. It does look like it's getting momentum. I would be willing to bet this thing is going to fly, but it may not fly until 2018 or 2020. I mean, it's lagging and lagging, but they have started to build some real hardware, and the launch pad area is starting to come through. They have poured some concrete and that, but they haven't built it as fast as they built the Olympic Village in Sochi. So I don't know when it's going to get done, but that's, yeah, and this is another big money project. So that's Angara. This is S3, which is Swiss Space Systems. And this is a little interesting company that they're talking about taking a big Airbus and then putting a little shuttle on the top and flying it like that. I met with the guys that they're talking about doing this and that, and I think it's an interesting concept, but I think they're fairly immature in their engineering, and it'll be interesting to see how it plays out. Now, they did sign a deal with a couple of Russian companies to provide the engines for the shuttle.
Be interesting to see what happens to the tail fin.
Well, yeah, that's what I say. A little not understanding, how things are going to work, is that tail fin won't probably stay in the final design when it's all said and done. But the two interesting things here is one is there's a DARPA project that is looking for a small reusable shuttle, and they want it to be able to put it's like 10, 10, 10, like in 10 days to fly 10 times and cost $10 million a flight. And this concept potentially has the capability to meet that. So these guys have formed a U.S. subsidiary and are looking at going after that type of contract. And it'll be, like I say, it'll be interesting to see if they're able to do it. But they're again looking at the small satellite market and wondering if they can go deploy. Now, this has all the advantages that Pegasus does too, is that you have a fully reusable first stage that's close to being off the shelf. And if you concentrate all your efforts on the little reusable shuttle that comes back, and that does offer realistic potential to reduce cost if you can get past the huge development costs. What's interesting on this is they've gone out and got a commercial sponsor, which is Breitling, to put their logo on it and sponsor them, and have fed in some of the money that started to go towards the development. So this bears watching. This is an interesting concept, and we'll see where they go. I'm hoping nobody has seen this one, because I hadn't seen this before. This is a Romanian rocket called HAS, the IAR-111 supersonic plane, and a Haas-2 rocket, and this is in Romania. And they built a mock-up, because that's a real mock-up in the central square in the capital in Bucharest, and then this Haas plane. And they also have big plans of a super booster that would look like that. I'm thinking this is going to be a fantasy scale one forever. But it is interesting, and it is amazing what you can do with the 3D graphics program. So that's something that's way out there, and we'll see whether it, because all of this is money. And then this is Meet the New Boss, same as the old boss. Orbital just announced a new rocket called Minotaur C, which is really a Taurus XL with a new name. And not to diss my friends at Orbital, but if you had 3 failures in the last 4 flights on Taurus XL, you'd give it a new name too. They're going to fly a mission called Skybox off of this, and they are actually going to take a large amount of the avionics and the payload fairing from Minotaur 4 that they're doing and move it over to this. And so Minotaur C is for commercial. And then they have a Minotaur 6, okay, which is an extended version of the Minotaur 4 by adding the same first stage. So they have the same first stage and then a second and third stage from Minotaur 4. So those are, Minotaur C is actually under contract, and it's supposed to fly at the end of 2016. Minotaur 6 is a concept at this point in time, but it has been proposed to the Air Force, and we'll see whether the Air Force takes them up. That would be not Delta II class, but somewhere a little bit more than an Athena II. It would be a big, small launch vehicle, but it's not really fall into the medium. So I think that's it. Yeah. So questions?
What about the British? The British have that rather futuristic looking
Skyline?
Skyline? Yeah.
It's Skyline.
Yeah, I didn't put that in here because I think the chances, I mean, that's a nice thing, but I don't see the Brits
Okay.
ever
I was going to ask
ponying
when,
up
when
the
you
money.
put your vision.
I don't see them, you know, it takes, I mean, just so you guys know, just in rough orders of magnitude, okay? It probably takes $500 million to do any of these launch vehicles, okay? I mean, people always start at it and they think they can do them for a lot less, but in reality, if you don't have $500 million to devote to something like this, by the time you get done, that's what you'll spend. And so a lot of these, it's strictly, they're great concepts. They make great PowerPoint and you can do great things, you know, and like that. But going and finding the money to go do it turns out to be the thing that'll make most of these never reach flight.
Well, you know the old saying, right?
What?
How do you make a small fortune in the launch business?
Yeah, start with a large one. Yeah, that's exactly it.
Dream Chaser?
I didn't put that up here, but I probably should have. Yeah, Dream Chaser is coming from Sierra Nevada, and quite frankly, it's just an oversight on my part. I should have put it up here. And it's a shuttle-type vehicle, really derived from lifting body stuff that was done, and they are talking about putting it on an Atlas. Now, they're talking because the next round of commercial crew is coming up and they wanted to show as much progress as possible. Whether they get fully funded by NASA or partially funded by NASA is still up in the air. And then, but Sierra Nevada is an independent private company that has invested a lot of money. They continue to choose to invest. So yeah, actually Dream Chaser's an oversight. I should have it on the charts as well.
CST 100 as well.
Yeah, CST, yeah.
To answer that plane question about why it hasn't been repeated, it's because performance. You don't get additional performance considering how many engines you put in. And considering that you're hauling a second airframe pretty much, you don't get as much performance as you might expect for doing it over and over. The only reasons why the Germans did it is because they're insanely smart.
What about X-Corp? Isn't X-Corp, wasn't there a Russian?
They're doing Lynx. It's going to be a small suborbital thing, yeah. So, right?
Yeah, in addition to the comments about the Siamese aircraft carrier systems, there was a proposal for a shuttle carrier aircraft of Siamesing two C-5s, and that was dismissed pretty quickly. I've seen sketches of it. It's pretty impressive looking.
Why not C-130s?
Do you think we'll see a North Coast ALS model?
Probably not a North Coast one. I don't know. Maybe at some point in the future. The big thing is they haven't got the design refined and settled down yet. I mean, that picture I had was a preliminary one still. They're still working through some of the engineering, but we'll see. I don't know. North Coast did a Pegasus at one time, so I can't rule it out unequivocally. Steve?
Yeah, Matt, could you just take a minute and describe the market for all these rockets?
Oh.
You mentioned CubeSats and big stuff. I mean, there's an awful lot of people building this stuff. Who needs it?
Well, yeah, that's a good lead-in question. So one of the things is there's I'll even start farther back than that. So when Athena was originally started, it was supposed to be the age of small satellites and a lot of launches. And one of the things that really drove a lot of that was Iridium put up a satellite constellation that was 72 satellites and required a lot of Delta launches and some Soyuz or Proton and like that. And then at the same time, there was supposed to be Teledesic that was going to put up a large constellation of communication satellites as well, except that by the time they got started downstream, cell phone technology had changed to the point where they put up towers instead of putting up satellites. So the small satellite industry kind of went away, and Athena was built to sort of take advantage of that, and Pegasus and Taurus moved in the same sort of mode that they were going to go do that. And then that was in the early 90s. That all kind of died out about 2000, and nothing really happened. But what's happened since then is in particular batteries, okay, solar cells, and some of the other associated electronic hardware that needs to go in space has rapidly decreased in size. I mean, we're seeing it in model rocketry and John's stuff right there. Those kind of accelerometer chips and everything like that now can go into CubeSats as well and fly in space as long as they don't see too much radiation. And most of the CubeSats are limited, so they have a 25-year life, so they can't go too high in orbit, and therefore they don't run into the Van Allen belt. So there's been a proliferation of stuff that used to be, the size of a school bus can now be the size of a Volkswagen Bug, that pretty soon can be the size of a dorm-sized refrigerator and have the same or more capability. And what's happened over the last 10 to 15 years is now satellite sizes are starting to decrease in size and volume and mass and not require a big Titan or a big Delta IV in order to get into orbit. So that market seems to be increasing. In addition to CubeSats, which are really 10 centimeters by 30 by 30, it kind of looks like a little loaf of bread. Those are rapidly becoming available, where a lot of universities are building, a lot of commercial guys are looking at them, and you can build one of those for $50,000 to $150,000 each. Okay. The problem with all of those, and even the problems with the smaller ones, is you still can't afford a dedicated launch vehicle. So there's a demand for launches for those kind of rapidly expanding CubeSats and smallsat markets, but there's no corresponding low-cost launch vehicle. So everybody is out looking for a way to maybe put those in cost effectively. And the problem becomes is while Moore's Law has taken and has applied a lot to the electronics that are in satellites and everything like that, there is no Moore's Law for propulsion. We went through that in the 50s and 60s, okay? And now to squeeze additional, like you asked about high performance propellants, those propellants are maybe 10% more efficient, have a higher ISP than what's out there now. There is no quantum leap in propulsion technology short of dilithium crystals that's going to push that out. And the other thing is it takes a finite amount of energy to get into orbit. You can do like Spaceship One, you can go up and come down, and that's kind of why they did that. But to reach orbital velocity, it takes almost the same amount of energy whether you put 1 kilogram, 10 kilograms, or 100 kilograms into orbit, and not much more to put 1,000 kilograms into orbit. So everybody's looking for, like a $1 million launch to orbit. Ain't happening in our lifetime, I don't believe, unless there's some other things change in more of a business structure, and there gets to be where there's a rapid launch on demand kind of thing. But where the satellites are getting smaller, there's going to be opportunities for these kind of small launch vehicles to maybe put multiples in some sort of ride share or piggyback. And since the satellite sizes have come down, this Minotaur rocket is probably, well, I'll just say between $50 and $70 million a launch, okay, which is a lot cheaper than a Delta IV Heavy, which is $350 million or more, like that. And so it's going to come down to a certain threshold, but beyond that, it's probably going to flatten out. So the beauty of these things is there's a lot of launch vehicles chasing potentially a lot of payloads. Whether there's enough payloads and enough people willing to pay, $10 million to get to space is questionable. If it's 20 million, there's a whole bunch that fall out. And if it's really, on a dedicated rocket, like something like that, if you were willing to buy 5, maybe you could get them at, let's say, $50 million. So it's all good to spend $150,000 on a CubeSat, but it still costs $10 to $50 million to get it into space. Somebody's got to come up with the money somehow, and that's part of the dilemma that things are in right now. NASA's starting to build a whole backlog of CubeSats, and when they fly big atlases and have extra payload space, they're putting a lot into them. and fly them. However, if you've got a $1 billion satellite on a $1 billion rocket, it's really hard to justify putting a $150,000 satellite underneath that. That might screw everything up. So they're starting to do some processes like that that lets them take advantage of that and not put the big satellites at risk. But the NRO just did one last year that was really the first kind of experiment of getting rid of them. They let the satellites ride on the back of one of the back bulkhead of one of the rocket engines rather than put it anywhere interfering near the payloads where it might damage their payload. So I mean, the market is moving towards smaller launch vehicles because smaller payloads. How this all shakes out in the next 10 years is going to be interesting to see, because the other significant thing, and again, Steve, we're going to see a move away from government-sponsored launches and launch vehicles and payloads and into commercial. And I really think we're coming into the second golden age of space, where on the first one, like what Wes was talking about, it was Mercury, Gemini, and Apollo and Shuttle, and the government paid for that all. Now we're seeing kind of what we joke about, the Billionaire Boys Club, okay, is starting to come in, and between SpaceX and Stratolaunch and Blue Origin, there's starting to now be commercial applications for the launch vehicles where people have enough money to invest, are starting to go do that. And the government's going to end up being a buyer of services and not a designer or developer to the most part. SLS will probably be the exception, but it's not unreasonable to think that SLS will be the last government-developed space launch rocket in the United States, and that it'll be private from there on out. And that's probably good. It's no different than the airplane industry, that the military started and bought a lot of that, but the military doesn't buy the most airplanes and sure doesn't buy 787s. Right now those are commercial customers. So it's an interesting market. I think we're seeing a crack of the window of where the second age where space is going to take off. It's not going to be government tax dollars driving it. It's going to be honest to God, bona fide people who want to make more money in the launch business, in the space business, than what they start out with. So we'll see. It's an interesting time. Other questions? Well, I certainly thank everybody then. Those up here that get the calendars.